My job here basically is working for Welsh Slate, and it's to the restoration of the old quarry sites. Now that involves, over a period of time, namely the autumn, going around various woods and copses, collecting different species of seeds from trees, shrubs, and also flowers as well, wildflowers and grasses. What I do then is I then bring them back here and I break the dormancies. Each species of tree has a different dormancy period, so it requires a different treatment, a different time period treatment. In my office over there I've got a heating cabinet and refrigerator which basically replicates summer and winter. Now once the seeds have been in there for the allotted amount of time, they then germinate. Once they've actually germinated, they then come out into the polytunnels and put in the seed trays to grow. As they come through and sprout, when they get to a certain height, they're then transplanted into root trainers, which are these, which allow them to grow on. Now Welsh Slate's 100% behind the restoration work here, because they work along with the environmental organisations and with local planning people, but also with the local community as well, because the slate tips there are part of their history. So they don't really want to see a blanket coverage of grass, but they want to see the tips improved but keeping the character of the tips. So the problem is to try and keep these trees alive until the roots form enough structure to get down to the nutrients where they can actually survive. Now what used to happen was years ago that these plugs, which you can see here, were put directly into the slate. Now you can see on there it's got a good root structure, but the depth of it doesn't allow it to draw up nutrients. So consequently a lot of them used to die. So what we've developed is over a time period is a different method of planting them out, which would allow the root structure to develop long enough to get the tap roots down to the nutrients and allow the fibrous roots then to spread sideways. So it's the time factor that's involved to allow it to do this. And the way that this is done is that we actually put them into sacks. Then eventually, normally between 6 and 9 months, that sack itself actually dissolves and breaks down because it's biodegradable. And then this is what you get. As you can see here, a sack that's been here for about 4 months and just allowed to weather. This tree went in the back end of last year through its dormancy period, and then it's been allowed to grow again. So you can see how the sack itself disintegrates, and also you can see through the sides here how the roots themselves are starting to develop, which allows that tree then to fight for itself. It just needs a decent break. Now the process that would actually go through in there is, obviously we've got these hessian sacks which we had especially made for the purpose of this job. We then take the hessian sack, fill it 90% full with compost. Just tap it down gently so it fills the sack up. Then you take the cell grown plant into the sack, and then you top up, just firming it all down like that. Then that has allowed that tree the nutrients, the space and the growing medium to start to develop. And once that tree then starts to develop, it's by itself. Although wherever we plant out, we do actually go around and check to make sure everything's okay, possibly very occasionally add extra nutrients just to help it along. But the tendency is, because it's such a nutrient-starved environment that it grows in, the lesser nutrients that the plant stock have, the better chance they have of surviving. Because if you feed a tree or a plant with nutrients, it gets used to it. So when it's planted out into a non-nutrient environment, what happens then is it dies, because it's been relying on hand-fed, not for being able to forage for its own food, so to speak. So consequently, the results that we have greatly improved on the growth from what it was a few years ago. So what we have here is about 3 years ago we did some experimental work with different blends of slate waste and of compost as well, using the green compost once again. And what we did, we blended in with the compost and slate waste different species of grasses, of wildflower seeds, and also some tree seeds as well. Now each blend has got a different ratio of a mix, so we wanted to see how these lines actually developed under the conditions. Because when we think of it now, we're 1,127 feet above sea level. So obviously the conditions up here are quite harsh, so it's defining which blend mix is going to be best for the restoration of the quarry. So as we can see here, there's quite a few trees, shrubs, etc. that have grown along with the natural grasslands. So this is what we're trying to do to develop a little bit further down. So what we do with these is we actually, it was set up as an area for seed collection and to see how the stuff would actually grow. So when it was fenced off to keep the sheep out, not necessarily the rabbits, because the heather needs to be grazed down a little bit. So what I can do is when it comes to the right time of the season, I can come up here and I can collect the different seeds, and also I use this sometimes as a seed base for the heather seeds, etc. And then I can take them back down and then take them through the process. But just what it means is that the species is solid. It's kept its genetic makeup completely, and it's got it built in that it's, you know, it's hardened to the area that it's being built, that it's being grown in. So consequently, it grows very well. So what I do before we actually start any planting out on the slopes, which you can see there behind us, is that I take an elevation reading. And at the moment we're standing at 867 feet above sea level. Along with that, I'll take a grid reference. There's 2 grid references that I take. And the reason for that is that we can actually then find out what's been planted where, what species been planted, and then we can go back, just keep on going back and look at the growth rates on it, so we can specifically say what species is actually being planted within the quarry itself.